Okay, let's dive right into this explainer. Today, we're going to peel back the layers of history's greatest scientist. We are moving right past that flawless marble statue you see in museums to reveal a fascinating, complex, and honestly, a deeply obsessive human being. When we think of the scientific revolution, that massive turning point that dragged European science out of its primitive state, one name stands above absolutely all others, right? Sir Isaac Newton. Born into a world where the ideas of Copernicus and Galileo were really just starting to challenge the established order, Newton emerged in an era steeped in both burgeoning natural philosophy and ancient myth. But the story we all know, the one completely etched into our popular culture? Well, it might just be a little bit too perfect.
Now, did an apple actually change physics? You know the famous story. The legend goes that in 1666, while drinking tea at his family's estate, Newton watched an apple fall to the ground and just instantly dreamed up the theory of universal gravitation. But historical analysis suggests this was likely just a fanciful tale, probably meant to mimic the ancient Greek mathematician Archimedes, who famously discovered the principles of buoyancy while taking a bath. So while an apple may have fallen in his garden, the true story of how Newton revolutionized mathematics, physics, and astronomy is far more rooted in intense, isolated labor than a single moment of whimsical inspiration. So let's uncover what actually happened.
Section 1. The Plague and the Apple.
Our real story actually kicks off in 1665, when an incredibly virulent wave of the bubonic plague struck the nation. With the plague killing upwards of 100,000 people in London, which was about 15% of the city's total population back then, universities were completely forced to close. This sent a young Isaac Newton fleeing from Cambridge University back to the safety of his family estate at Woolsthorpe. This self-imposed isolation became what is known in the history of science as his miracle years, or the Anni Mirabilis. It proves that sometimes a complete lack of interruption is the absolute ultimate catalyst for genius. Much like Albert Einstein would experience centuries later in 1905, Newton utilized this terrifying period of societal shutdown to completely reshape human understanding. Isolated out in the countryside, far away from the structured and frankly outdated university curriculum, Newton was finally free to just follow his own penetrating mind.
And when you look at this timeline, the sheer volume of his output during those miracle years was just staggering. Within mere months, he fundamentally expanded our grasp of mathematics, physics, and optics. First came the binomial theorem, which laid the very basis for modern calculus. Then, he built on the work of Galileo and philosopher René Descartes to study mechanics and weights. By studying how objects collided, he formulated his laws of physics, including that deceptively simple third law we all know: every action has an equal and opposite reaction. He figured out that particles actually attract one another, and that this gravitational pull correlates directly with the mass of the objects and the distance between them. And the craziest part? All of this was carefully recorded in his private notebooks, which he quietly tucked away in a drawer for literally decades.
Now, while gravity was definitely his most famous pursuit during the plague years, his work in optics was just as groundbreaking. To figure this out, he literally locked himself in a dark room, allowing in only a single narrow beam of light. He placed a glass prism in front of this beam and refracted it onto a wall over 20 feet away. And what he saw was a color spectrum 5 times longer than it was wide. This definitively proved that white light was not homogeneous, which was a belief held all the way since Aristotle in ancient Greece, but was actually heterogeneous. It was made up of different parts, which he called corpuscles. This corpuscular theory of light would eventually become the foundational basis for Einstein's discovery of photons 2.5 centuries later. Section 2. The Solitary Scholar. To truly understand his unparalleled genius, we have to understand his incredibly lonely origins, because these early experiences heavily shaped his aloof, difficult, and profoundly reclusive personality. Newton hailed from rural England, from a family with absolutely no tradition of scholarship. In fact, his father and several other family members were completely illiterate. Born sickly and premature, he honestly wasn't even expected to survive. His father died months before his birth, leaving behind a sizable farm estate. But when Newton was just a young boy, his mother abandoned him to live with a wealthy new husband, leaving Isaac to be raised by grandparents he seemingly despised. And when his grandfather died, he left Isaac absolutely nothing in his will. This deep sense of abandonment pushed him into intense study. Even when he finally made it to Cambridge, his relatively humble background meant he was admitted as a lowly subsizar. That basically meant he had to earn his keep by cleaning the college and wasn't even allowed to dine with the wealthier students. He was totally marginalized, which only drove his focus deeper into his books. He never married, appeared largely asexual, and just kept to himself. But by 1669, his undeniable brilliance led to him being appointed the Locution Professor of Mathematics at Cambridge, where he was earning £100 a year. Now, the job was hardly demanding.
he was expected to deliver just one lecture a week during one term of the year. Yet he often delivered that single lecture to a completely empty room. Why? Because the few students at Cambridge simply couldn't comprehend his highly advanced mathematical equations. But Newton didn't mind one bit. He used this vast amount of free time to refine his theories and physically build instruments, like telescopes and prism rings, to showcase his findings.
Section 3. Alchemy and the Apocalypse.
Let's pull back the curtain on his hidden life, because this is where things get really wild. While we picture him strictly as a rational natural philosopher establishing the hard laws of physics, the truth is far more mystical. You have to remember, in the 17th century, the boundary between science and what we would today call magic was incredibly blurred. Alongside his flawless scientific logic, Newton was deeply obsessed with esoteric thought. He moonlighted heavily in alchemy and Hermeticism. Hermeticism was basically a pseudo-religion tracing back to a mysterious ancient figure known as Hermes Trismegistus, and it blended Neoplatonic philosophy, ancient Egyptian lore, and early Roman science. Like many giants of the scientific revolution, including guys like Copernicus, Kepler, and Robert Boyle, Newton fully believed that ancient texts held lost knowledge systems. A visitor to Newton's study wouldn't just see telescopes, they would see scientific instruments specifically designed to test substances in the mythical quest for the Philosopher's Stone, that legendary substance believed to turn base metals into gold. Actually, he spent more of his life trying to turn base metals into gold in his private laboratory at Cambridge than he ever did studying physics. He acquired all sorts of strange substances and compiled what's known as the Index Chemicus, logging his bizarre experiments. He developed files spanning thousands of pages of notes on alchemy, much of it written in arcane symbols that only he understood, and which remain completely impenetrable to modern readers today. At one point, he even strongly considered abandoning physics entirely to focus solely on this alchemical research. And his obsession with hidden knowledge didn't stop at chemistry either. Newton was fascinated by the esoteric historicity of the Old Testament. He wrote extensively about the Temple of Solomon and dove incredibly deep into Christian theology, holding nonconformist views that outright rejected the Holy Trinity. Based on his obsessive, esoteric analysis of the apocalyptic book of Daniel, he calculated the exact dates the world could come to an end. His final calculation? The year 2034 or perhaps 2060. So we might not have long left, at least according to history's greatest scientist.
Section 4. Rivalries and the Royal Society.
Leaving the apocalypse behind, we find that Newton's extreme reclusiveness eventually morphed into some pretty bitter, toxic rivalries with his peers. As his fame slowly grew and he was elected to the Royal Society in London, he found himself constantly clashing with the established scientific community. For example, he engaged in a fierce, years-long academic debate with the renowned Dutch astronomer Christian Huygens over the very nature of light. Huygens, who had already discovered Saturn's largest moon Titan, strongly disagreed with Newton's corpuscular theory. Huygens proposed instead that light traveled as waves producing secondary wavelets. They battled back and forth through correspondence for years, a true clash of two monumental intellects. But honestly, that was a polite disagreement compared to his massive conflict with Gottfried Wilhelm Leibniz. Leibniz was a brilliant German polymath who independently invented calculus at the exact same time Newton did. Because Newton had kept his 1665 findings hidden in a drawer for decades, a massive feud erupted later in their lives over who actually discovered it first. Newton, really showing his darker side here, disingenuously used old letters he had exchanged with Leibniz to falsely accuse the German scholar of plagiarizing his work.
The most toxic rivalry of all, however, was with a man named Robert Hooke. Hooke was an older, very established natural philosopher who famously helped rebuild London after the Great Fire of 1666. He viewed the younger Newton's emergence as a direct threat to his own eminence. The two engaged in a bitter, nasty feud over optics and gravity that lasted for decades. Hooke basically marginalized Newton within the Royal Society for years, but Newton played the long game. After Hooke died in 1703, Newton rapidly ascended to become president of the Royal Society. And what was his first order of business? He reportedly wiped all visual trace of Hooke from the building, allegedly having every single portrait of his deceased rival completely destroyed. Talk about holding a grudge.
Now, despite these pretty petty feuds, Newton's administrative abilities were actually extraordinary, which led him directly into government service.
In the 1690s, England was facing a severe economic crisis due to coin clipping, which is where people illegally shave silver off the edges of coins. Appointed Master of the Mint in 1696, Newton executed a total recoinage, minting an astonishing £7 million worth of clip-proof coins in just 2.5 years. To put that into perspective, that was roughly the same amount the Mint usually issued over a 30-year period. It was a staggering logistical achievement.
Section 5. The Principia and Legacy.
Ultimately, despite his deep dive into alchemy, his apocalyptic predictions, and those vicious academic feuds, Newton's legacy was forever cemented in the 1680s. After decades of fiercely guarding his secrets, he finally published the grand synthesis of his life's work. Published in 1687, the Philosophia Naturalis Principia Mathematica fundamentally changed human history. As theoretical physicist Stephen Hawking famously stated, it is quite simply the most important book ever written on the hard sciences. While predecessors like Galileo and Kepler had observed how the planets moved, Newton's Principia was the very first to provide the definitive mathematical and scientific explanation for exactly why they moved that way. He explained equinoxes, ocean tides, and the irregular motions of the moon, pulling the whole universe together under one beautiful unified theory of gravity.
Looking at this table, you can see how brilliantly structured his masterwork was, broken into 3 distinct volumes that move from the abstract right to the universal. Book 1 lays down the detailed theories of gravitational pull and the laws of motion he first sketched out during those plague years. Book 2 systematically dismantles the incorrect theories of earlier philosophers like Descartes. And finally, Book 3 applies these hard rules to the real world, mapping his laws of motion directly onto the vastness of the heliocentric solar system. It proved once and for all that the exact same forces dropping an apple and Woolsthorpe were holding the planets in orbit.
Now, centuries later, we know his theories weren't entirely flawed. Newton's laws of gravity didn't account for extreme cosmic phenomena like black holes, simply because he had no technological way to measure them back in the 17th century. Eventually, Albert Einstein's theory of general relativity revised Newton's work. And today, modern tools like quantum computing are actively revising Einstein's work. But this doesn't diminish Newton at all. Science is a journey. It's a constant evolution of knowledge. Each generation builds on the last. Just as Einstein provided stepping stones for today's quantum physicists, Newton provided the vital, absolute foundation that made Einstein's breakthroughs possible in the first place.
When we step back and look at Isaac Newton's brilliant, bizarre, and incredibly complicated life, it leaves us with a really profound question. We know that while Newton was formulating calculus in England, Gottfried Wilhelm Leibniz was discovering the exact same mathematical principles hundreds of miles away in Germany. We've seen similar historical patterns too, like Charles Darwin and Alfred Russel Wallace independently discovering evolution at the exact same time. So it leaves us wondering, was Newton the ultimate radical, lone genius who single-handedly dragged humanity into the modern age? Or do societies simply reach an inevitable threshold of knowledge, and Newton was just the most brilliant man standing in front of a door that was already unlocking? Let that sit with you for a bit as you view the world he helped explain.